All right, let's get right into it. Today, we're gearing up for a pretty serious mission. We are about to take a journey to one of the last, and I mean last, true frontiers on our planet, the deep ocean. It is a world of absolute, crushing pressure and eternal darkness. So, let's get our briefing and start the descent.
So here's our mission plan. First up, we're going to really try to wrap our heads around the sheer scale of this mystery. Then, we'll talk about how we survive in an environment that is so hostile. After that, we'll meet our robotic explorers, learn how they manage to see in total darkness, and finally, uncover the absolutely incredible life they've found.
So just how big of a mystery are we talking about? Get this, over 80% of our planet's oceans are still completely unexplored, unmapped, and unobserved. Think about that. We have better, more detailed maps of the surface of Mars than we do for the vast majority of our own world. That huge unknown territory, that's exactly where we're headed.
Okay, let's begin our descent. We are venturing into a realm that has trenches so deep you could drop Mount Everest right into them, and its peaks still wouldn't even break the surface. And no, this isn't science fiction. This is right here, on planet Earth.
Now, before we can even think about exploring, we've got to understand what we're up against. The deep sea is, without a doubt, one of the most hostile environments you can possibly imagine. So to go there, we have to prepare for conditions that are just completely alien to us.
Our journey really begins at the 200-meter mark. You can think of this as the point of no return for sunlight. Once you cross this line, the world we all know, the one powered by the sun, it gives way to an empire of absolute total darkness.
And down in that darkness, we face three enormous challenges. First, obviously, is the lack of light, which makes seeing anything totally impossible. Second, you have near-freezing temperatures that can stop machinery and life dead in its tracks. And third, the biggest, most relentless challenge of them all, the pressure.
To try and put that pressure into perspective, just try to imagine the weight of 50 jumbo jets, stacked one on top of the other, pressing down on you. That is the kind of force we are dealing with at the deepest points of the ocean. Without some serious protection, any machine, any organism would be just instantly crushed. So, how in the world do we overcome those lethal conditions? Well, the short answer is, we don't go ourselves. We send proxies. So let's meet the incredible technology, our robotic pioneers that we send down into the abyss on our behalf.
Now, the general name for our deep-sea craft is submersibles, and these are not your average submarines. They are purpose-built exploration machines. They're built from unbelievably strong materials like titanium just to withstand that pressure, and they basically act as our eyes, our hands, and our scientific labs in the deep.
These unmanned submersibles come in two main flavors. First, you have ROVs, which stands for Remotely Operated Vehicles. Think of these as our hands-on explorers. Then you have AUVs, the Autonomous Underwater Vehicles. These guys are more like our long-range scouts, and they each have a very, very specific job to do.
And you can really see the key differences here. The ROV is physically tethered to a ship with a pilot flying it in real time. This is perfect for, say, getting right up close to a hydrothermal vent or collecting a very specific rock sample. The AUV, on the other hand, is basically unleashed. It follows a path we program for it, mapping huge areas of the seafloor all by itself before it comes back with the data. So you've got two different tools for two very different jobs.
Okay, so we've got robots that can survive the pressure. Awesome. But how do they get around in total, absolute darkness? I mean, you can't just flip on some headlights and see for miles down there. The solution is pretty ingenious. We have to learn how to see with our ears.
And the tool that lets us do that is sonar. It stands for Sound, Navigation, and Ranging, and it is, without a doubt, the single most critical sense for deep-sea exploration. It's what allows our robotic scouts to paint a detailed picture of the world around them using nothing but sound waves.
The concept behind it is actually surprisingly simple. The submersible sends out a sound pulse, a little ping. That sound travels out, hits something, like a mountain on the seafloor or maybe a shipwreck, and then it bounces back as an echo. By measuring the tiny amount of time it takes for that echo to return, a computer can figure out the exact distance. And by doing that thousands and thousands of times, it builds a detailed 3D map of a world that no human eye has ever seen.
So, we've conquered the pressure, we've conquered the darkness, we have our maps, we're collecting samples, we've figured out the how of our mission, so now we get to the payoff. What have we actually found on this incredible journey? Right? After all of that effort, after developing all this amazing technology just to survive in an environment that's more hostile than outer space, what are the treasures the deep sea has revealed? What makes it all worthwhile?
Well, we've found things that have completely rewritten our biology textbooks. We discovered these things called hydrothermal vents. They're like volcanic chimneys on the seafloor, and they support entire ecosystems that thrive not on sunlight, but on chemical energy coming from inside the Earth itself. We've found bizarre, incredible creatures that create their own light through something called bioluminescence, using it for everything from hunting to hiding, basically painting the eternal night with living fireworks. In a place we once thought was a barren wasteland, we found life, and a lot of it.
And really, that's the big takeaway here. This whole thing isn't just about finding weird-looking fish. Every single discovery we make in the deep ocean teaches us something new about the absolute limits of life, about the history of our planet that's locked away in the seafloor, and about the fundamental rules that govern biology, not just here, but maybe, just maybe, elsewhere in the universe.
And this all brings us to one final, kind of mind-blowing thought. Everything we've talked about, the vents, the glowing creatures, entire ecosystems running on chemicals, all of that was discovered in the tiny, tiny fraction of the ocean we've actually managed to visit. It really makes you wonder, right? If this is the amazing stuff we found in the little bit we've explored, what else is waiting for us out there in the other 80%?